Welcome everybody. So we're pretty excited for this new major release, Kokkos 5.0. We are gonna start, sorry, with a few announcements, and then as usual, we will go over the detail of what changed since the last minor release, all the new features and anything that could break you, just as we usually do it. Um, so yeah. All right. As always, you can find everything about the project, about everything on the one URL that's not on the slide, which is kokkos.org. From kokkos.org, you can find everything, the organization, GitHub, or tutorials. And if you are not already on there, you should join us on Slack. There is under community a chat tab on our website, and join us. That's the best place to get your question answered, and maybe discuss a few things before you go and implement something you want to contribute. We are still kindly asking you, if you haven't done it before, to help us advertise and discover what you've done. So we have a list of applications that lives on an old Kokkos issues, so that's a good place to doing. We are about to overhaul our website, and the instructions are gonna be updated soon. We'll post it on Slack. But as of now, it's still the best way of tell us what you've been doing with Kokkos. We just really want to hear it. Another mean of doing that is if you look on the Kokkos GitHub organization, you're going to see on the right-hand side, there's little labels. There's a Kokkos label, and you can discover Kokkos project with it. So if you haven't done it, we would appreciate if you would put that label on your project if it uses Kokkos. Same thing, it helps us keeping track of who uses us, and sometimes that might be a good way of having people find your project. So yeah, briefly, so what's coming up in the near future? So in January, CEA is actually organizing a training in Saclay. It's near Paris. It's going to be 1 day of basic training, the usual thing with the class, and they will actually go over the exercises, and then an exciting 3 days of hackathon for a deeper dive with some of our Kokkos experts. The registration is open, it's free. But it's mandatory, so it's first come, first served. We are gonna post this slide as usual online afterwards, so you can find these links if you haven't had the chance to write it down now. But yeah, we encourage all of you, if you are able to go to participate. Yeah, anyway, we'll remind everybody about these events on the mailing list in the near future. Okay. So we are also proud to announce, so HPSF is organizing in February, at the end of February, its first HPSF Community Summit event. And it's going to be hosted by the university in Braunschweig, which is near Berlin in Germany. It's going to be over 3 days, so at the end of February, as I said. And we will host a Kokkos user group meeting there. It is a successor slash much broader impact to what you might have known in the past as a European Trilinos and Kokkos user group meeting that was happening, but now HPSF is helping out with this. So there will be a few HPSF plenary talks. So it's a chance to meet like all the other Kokkos developer and users. It's going to be you can meet probably we're going to have our European presence, and we'll try to send a few developers from the US as well. But yeah, you should submit if you are able to attend. There is a link already online to submit your talks, and yeah, there will be Trilinos, Spark, and a lot more. Okay, and yeah, so we recently, I think last week or 2 weeks ago, we finally have an official date for the the next High Performance Software Foundation conference. That's going to be in March. This is going to be at the same venue that we had the one last year. That is downtown Chicago. It was quite a nice venue if you haven't had a chance to come. And just like what we did in May this year, we are going to have hold a Kokkos user group meeting there. The layout of the full meeting is going to be so it's extended. We're going from 4 days to 5 days for the overall conference, and it's going to be 2.5 days of the main HPSF plenary. You should look at the call for a proposal. There is a lot of themes that are relevant, beyond Kokkos. So if you want even more reach, you should think about submitting to the main track. But then the second part of the conference is going to be project meetings. We're going to hold a 2-day meeting, just like what we did last year. The call for submission on the Kokkos website is ready. We're going to post it later this week, and we're going to announce it on the mailing list. But essentially, it's going to be a very similar format to what we did last year. And yeah, we are looking forward to seeing a lot of you guys, hoping to get people returning and new talks, telling us about what's new. Feel free if you have pain points to come and tell us what needs to change, we need to improve. And yeah, it's a tribute for you to show all the cool things you've been doing with Kokkos. Yeah, so stay tuned, and we will post the slides, and we'll let you know on the mailing list about all of this. So other news, we are participating as a project to the Sustainable Research Pathway program, which is a program for interns to get to work on projects that they would never interact with otherwise. It's an initiative that's supported by HPSF. So if you are students or you have students that want to get involved, I think it might still be doable. But more generally, yeah, if you're students and you want to interact more with us and maybe do an internship, yeah, reach out to either Christian or me or Julien, and we can see if there is possibilities. Yeah, if you haven't done it yet, we have fairly recently, we've started using mailing lists that are generously provided by HPSF. And so there is, in particular, an announcement mailing list, which is really low traffic. It's the big announcements like Kokkos user group meeting are telling you guys about this briefing. Yeah, that's it for the high level. Now the guys are going to go over what changed. Nick?
All right. Yeah, so I'll give an overview of the main feature highlights of the Kokkos 5.0 release. So if you can move to the next slide, please. Yeah, so with the 5.0 release, we're going to be requiring C++ 20. This is something we've talked about for a while. So along with this change to C++20, there's going to be an update to the compiler requirements. So we've summarized it in this table. I just want to emphasize, even though it's included on this table, that Microsoft's compiler is still on relatively experimental support, because our main compilers are going to be GCC, Clang, Intel, and NVCC, and ROCm. Next slide, yes, thanks. So with 5.0, we're going to be turning off Kokkos enable deprecated code 4 by default. You can still turn it on, but we recommend that if you need to turn it on for your application, that you should examine what deprecated code 4 features you're using and try and refactor the code to because these features might be these features will be removed in the future. If this is a big issue, you should definitely talk to us, but I just want to make sure that everyone is aware of that. Also, with the 5.0 release, we've removed 2 features that were like, for example, we removed tasking, which I don't think had many people using it at all, and then also the makefile support. So both of those were announced a while ago, but just want to make clear that those were removed. Along with the 5.0 release, we are re-enabling the MD-span-based view implementation. So it's an extensive refactoring of Kokkos U. It uses the MD-span library that we maintain that also has backports to C++17 and C++20. You can find it in our GitHub org. The main goal of the refactor is to provide better library interoperability, more API flexibility, and reduce the maintenance burden. So in principle, this should be fully transparent. Your existing code should just work. And we've done a lot of testing around this. And kind of the benefits for applications is they can use the same customization points as MD-span, including accessors and layout mappings. And in the future, we may provide a mechanism for users to customize these. So we definitely appreciate some feedback on that, and also if there's any issues you run into with the new view implementation. Next slide, please. Yeah, so that slide is, I'm sure you've seen it before if you went to previous release briefing. So we had first enabled this in 4.0, but then we disabled the new view implementation in 4.7.1. And the main thing was some compatibilities with Trilinos and Staccato. So we've done a lot of work in fixing those incompatibilities, and now those should be addressed in the 5.0 release. There's also some reports of performance regressions, specifically with regards to indexing. So we also provided some fixes to those performance regressions. There's also, with the new view implementation, there potentially may be some issues with older compilers, just because with compiler bugs and so on. So even though with the C++20 requirements, a lot of the older compilers are not going to be allowed anymore. We still have gotten a few reports of some minor issues. So if you run into any of this, please let us know. But also, our general recommendation is that if it is possible with your toolchain, you should try and upgrade to, especially CUDA, to the latest CUDA versions. Well, rather latest CUDA version in 12.x series, and at least GCC 12 if possible. Just because that will give you the least amount of headaches. All right. Also, with the 5.0 release, we now support C++20 modules. These were primarily tested with Clang and expected to work with host backends. We've separated our code into modules that more or less mirror our header files. So Kokkos.core is going to be one module, and then a lot of the containers are going to be split into separate modules. You see all of the bits set through unordered map ones. And then similarly with our algorithms, Kokkos Random and Kokkos Sorter in their own modules, while all of the still algorithms are in one combined module. We also have a module for SIMD. So here's an example of how you can use these modules. It's very straightforward. I do want to emphasize that the module support is still relatively experimental because we don't have a lot of people who are using this right now. We've tested it, but of course we would like your feedback if you plan to use these. There's some minor caveats. So one is that in the example you can see on the left, you need to link to Kokkos Core rather than Kokkos : Kokkos. And then what's very important is in your C++ code, when you're importing Kokkos.core, because of the way modules work, in order to get all of the Kokkos macros, like Kokkos Lambda and so on, you need to make sure you still include Kokkos macros. If you don't do that, you will not get any of our macros. That's just how modules work. All right, so now on to some general enhancements. Oh, next slide, please. Yeah. So we've improved performance of view initialization on host parallel backends. So we now pick the best initialization method, either using a parallel for or a memset, depending on the size of the allocation. And we have based that based on benchmarking results. Now an ordered map can support view as a value type, but there's a couple of caveats with regards to that. Need to use the sequential host init tag for that. Sequential host init tag can also be used for other value types, but it needs to be used for view as a value type. And also the view as a value type also requires that unordered map is in a host accessible memory space. So we have an example of using that there at the bottom. Right, next slide. We also continue our support for keeping our SIMD library in step with the standard. So now we support type conversions between SIMD types. We've improved the usage of reduction identity. So now that if you use reduction identity with a half type or B half type, it will return half type or B half type instead of a float. So this is relevant for things like sum, prod, min, and max. We've improved our consistency with Kokkos array, compatibility with the standard library, adding begin, cbegin, and cend methods, and also add missing no except specifiers to some methods. Now we also print the commit hash of any embedded dependency, so you know exactly what version of the embedded dependency we are using. It will be printed out during configure time, and also when calling print configuration. With the these little atomics, we now use Clang atomic min-max and DCC style built-ins. I think Jakob will explain more about that in some of the backend discussion. We also reduced our memory usage for tests. That probably shouldn't be relevant to most people, but in case you're running Kokkos tests on a memory limited system, that'll be useful. And also we updated some error reporter, including adhering better to the Kokkos naming conventions and changing Git reports to return values. And we'll have more details on that later. Right. Now we also have a new execution policy trait, which is the static batch size. So this allows you to have specify an unrolling factor at compile time. Right now, it's only can be used inside of the CUDA backend with the range policy, but we might be able to expand that in the future. All right, thank you.
Okay, now we're gonna give the floor to Jakob.
All right. So we're gonna start for the backend updates. We're gonna start with CUDA, and the first thing is gonna be we implemented 128-bit compare and swap on device. you need a Hopper or newer device for that, and you need CUDA newer than 12.8 for that to work. But switching from our lock-based atomics to the compare and swap-based atomics, you get a pretty decent speed up, about like 60 times on H100. And we had a Blackwell consumer grade graphics card that was a bit slower. These results were look the same for int 128 or for Kokkos complex, but these are without contention. So that means it's just measuring how much the performance benefit we get from switching from the lock-based implementation to the CAS-based implementation. These threads do actually not fight over addresses. And what you can see is if you look at the fetch division, where you divide the operation, you cannot measure the CAS independent of the operation. So you see if your user-defined type, it works for any user-defined type with 128-bit. If that type has a very costly division operation, then you will not get the same speed up as for example, for add. So, but to see what this, the full picture of the atomics, we also have to look at the contention. And this is just on Hopper. We did an atomic add with Kokkos complex of double, so 128-bit type. And we had a range policy with 10 to the power of 8 workers. And you see the number of addresses on the x-axis. If you go to the left, you get more contention, so more threads are fighting to write on the same axis. And on the y-axis, you see how much it slows down. And you see both the lock-based, which is the old implementation, and the CAS-based, which is the new one. They basically scale the same. If your contention rises, they will just get into exponential scaling. So these atomics are basically good if you use them in the region that is in this graph between 10 to the power of 5 and 10 to the power of 8, which we didn't plot here, but where the gap between the two implementations is biggest, that's where you get the best speed up. So just because we switch to a different implementation or like the hardware-based CAS doesn't mean that you can just atomically add or do something without looking at contention. What else did we do for CUDA? We previously, that's kind of an internal thing, but we had 3 main versions of how to launch a kernel. You did not, if you didn't really dive in deep into how we do it, you did never touch this. But CUDA now allows 32 kilobyte of arguments for kernels. So your functor can have 32 kilobytes of memory. And that allows us, like it was increased from 4 kilobyte. This allows us to get from the 3 launch mechanisms we had down to 2, basically sidestepping launching from constant cache. For what are you expecting to see for this? Like for very small functors that were below 4 kilobyte, you don't see any change. Same for very large functors, larger than 32 kilobytes. But the ones that are in this range, they will have lower latency and they will run faster. This means that if you adhere to Kokkos semantics and you fenced in the right places, and you did not rely on launch latency for your program to be valid, then you shouldn't see any difference. If you did that, like if you have a missing synchronization, you might get hit by this because timings will change. Right now, this only works with CUDA and NVCC. It should work with Clang, but this is not yet implemented. It's on our to-do list. And it does not work for GPUs older than Volta because it was not enabled for them by CUDA. All right, for the SYCL backend, this is going to be quick. SYCL now uses unsigned integer types as size type in the SYCL type. This is basically to unify it across all backends. The other ones were already doing this. We don't promise anything on the size of the integer, but it is an unsigned integer type. That is what you can rely on now. OpenMP target, this is going to be a bit funny because we fixed the bug that we now allow parallel scan with the range policy that started or starts at an index that is not 0. Previously, we required that. Now we fixed that, but we also, since no one, or we didn't really have users for OpenMP target, and it never reached a parity with the other backends, and also kind of very consistently showed lower performance than the native backends. We just scheduled it for removal. It's not yet, but it will be in future releases. But we've still fixed the bug, and you will see why we did that, because in OpenACC we had exactly the same bug. That's how we noticed. It's also fixed in OpenACC. Additionally, OpenACC now supports Kokkos Random, but that's a little bit of a caveat. It can be inefficient if you are using that with a team size that is different from the default team size due to some implementation details. Come on. All right. Furthermore, it supports partition space as an API. We don't make any promises, but we reserve the range from the async IDs 64 to 181. We assign them in a round robin. We do this in order to hopefully not clash with other libraries if they use some of these IDs. But as said, this is just what we do now. We reserve to change that. And also, if you hit that, just let us know that you ran into problems. We now support custom scalar reduction with parallel reduce and the range policy, and we support both built-in reducers with your custom scalar type and custom reducers also with custom scalar types. All right, finally, HIP. We had a performance regression that we introduced in 4.6 for lightweight kernels. This is one of these launch mechanisms that previously we now reduced for CUDA to 2 from 3. But these are internals, and these only will show up on your radar if you are already diving pretty deep into what you can do with Kokkos. But the performance regression is fixed in 5.0 now. We also prefer a smaller block size for parallel 4. If the parallelism you request is less than the available concurrency, which fixed like performance problems, we now use, as Nick already hinted, atomic built-ins for atomic fetch, min, and max for floating point types, instead of like falling back to the log-based tables. We now use the device intrinsics. And we added support for Navi 4 architecture. This is mainly like to consumer-grade GPUs. And now the can of worms, ROCm 7.1. So our recommendation is avoid it if you can. Now we are working on fixing a lot of things. What we know on MI100 and MI200, you should use Kokkos enable impl hip malloc async and set it to off. Then these seem to pass the unit tests. On MI300, we had problems in some configurations not even being able to compile. In others, it seems like we need enable hip malloc async also be set to off. But these are ongoing works. We hope to have fixes in the bug fix release or in 5.1 latest. All right, then for build system updates, this was already mentioned. It's not unsurprising. The enable deprecated code was bumped with the major version bump from 4 to 5. So 4 is now per default off and 5 per default is on. The CMake requirements, the 3.22 is now the new minimum. If you want to compile in CMake with CUDA language support, then you will need 3.25.2. This is due to CUDA and C++20 only being added in CMake. It should be 3, not 2. Sorry, in 3.25.2. I think no one is using CMake 2 anymore. I hope so, at least. All right. And then we have a new interoperability feature. So just to disclaim, if your code is already working now and you're not doing interoperability or having problem with that, you don't need to worry about this, even though it might sound complicated. But what we do is we now offer support for multiple CMake languages in one Kokkos build. That means we allow that a single Kokkos installation that you installed can be used in different CMake languages. This is always going to be CXX. And if the backend you enabled has a corresponding language in CMake, like CUDA and HIP do, then you can also use the same Kokkos installation in these languages. What we do under the hood is we set the flags that we need as Kokkos to work for all of these CMake languages that work with the selected backend. And there is this intricacy that we sometimes use Kokkos Launch Compiler to swap the compiler for CXX. These rules basically stay unchanged. So if you use the CUDA backend without any CC wrapper as a CXX compiler, we will add Kokkos Launch Compiler for you. You can enable this multiple language support with a CMake flag, enable multiple CMake languages. And what can you do with it? Like this is an example CMake. Okay, you do find package Kokkos, and then you say you want to add a library that uses .cu files, and that library is in CMake identified as a CUDA language. And this language, this library now links publicly to Kokkos. Okay, that's fine. But you can, in the same project, now also use Kokkos in a CXX project. So you have another library that is CXXlib. It has CPP files, and it also links to Kokkos. And now you want to create a executable that links to both of these languages, and all of this will work without problems with the new multi-language feature. There is a little bit more extensive example in build CMake installed multi-language that also is like language agnostic. This here is just for CUDA as an example. For Windows, which we kind of still support experimentally, we now have support for shared library builds on Windows. This basically means if you build Kokkos on Windows in CMake with build shared libraries equal on, you will not fail. But what we do under the hood is we use Windows export all symbols to set to on, which basically means the DLL that you will generate will have a bunch of exported symbols that you will probably not need, but that was the easiest way to get it to work. If you run into problems with that, just let us know. We are happy for any feedback we get on this. All right, next is going to be deprecations.
Chris, the floor is yours.
Yeah. So
Yeah, let's go. You go.
okay. So first off, as previously mentioned, we added the CMake option for enabling deprecated code 5, which is on by default. There are already quite a few items which are guarded by this option. So we deprecated the Kokkos attribute no discard macro. It was a leftover from pre-C++ 17, and you can actually just replace it with the standard no discard attribute. For the owning and observing row pointers, it was never meant to be public, and it was also undocumented, and we didn't detect any usage downstream, so it should be okay. And you can just use row pointers instead if you actually used it. We deprecated the random XOR shift pool init method, and we replaced it by a constructor. So instead of constructing your default XOR shift pool and calling the init method, you can directly call the constructor with the same arguments. And if you want to reinit your object, you can just reassign your variable. We deprecated the where expressions and contour expressions in SIMD to better align with the SIMD proposal for the C++ standard. All the functions which were contained in those classes, so for example, to do partial loads and partial store will or have already been replaced. We also deprecated support for using nested OpenMP parallel regions without setting the OMP nested environment variable. Because when you launch the, let's say, parallel for in an OpenMP region without this variable, it would sometime fail or sometime succeed. Now we always abort if we detect such a usage. And one associated change is that we deprecated the creation of OpenMP exec space instances inside OpenMP parallel regions. Okay. Inside Vue, we deprecated quite some aliases. So I think the most important one is the host mirror, which will now be host mirror type. The other ones, we don't expect many users to come into issues with those aliases. And they are all still available in deprecated code 4, but you should change to the new aliases. And we also did some deprecations in error reporter. So this is a helper class in the experimental namespace and the container subpackage to collect error reports comprising of an index and another type. We changed the function names to better align with what we do in other parts of the code. And we also added support for structured bindings for the getReports method. And as a reminder, the deprecated code 4 is now off by default, and we start to remove features. Okay, so for the breaking change, one of the most important one is that we do not support makefiles anymore. This has been deprecated in 4.6, but this was actually discussed way before 4.6. And this removes the burden of maintaining both CMake and the makefiles because we sometimes didn't have feature parity or run into other issues. So we can now allocate more developer resources into improving our CMake based build system. We removed support for the Kepler architecture because CUDA removed support for it in the CUDA 12 release. So we removed the corresponding Kokkos Arch options. And we increased the minimum version requirement for Google Benchmark. This will mostly be visible on the developer side and maybe on user side if you did run benchmarks. But this shouldn't have a big impact anyway. Okay, we also removed task-based parallelism because it was actually rarely used and it was deprecated since 4.5. And it was only implemented for CUDA, so it shouldn't be too big of a loss. We now always abort when calling parallel for scan or reduce before Kokkos initialize or after Kokkos initialize. Sometimes in some situations this could work, but this was never meant to be illegal. So now we always abort if you call a parallel construct without Kokkos being initialized first. And we changed the behavior of Kokkos graph submit when we don't specify an execution space. So before it used the space that was specified during the graph construction, but now it aligns with other parallel constructs in Kokkos and it chooses the default execution space. We changed the way we did use the default SIMD vector width. So before it was we used the same width as the largest types available. So for example, the SIMD of float would have the same width as the SIMD of double. So on AVX 512, it would be 8 and 8. But now we use by default the largest available size. So on AVX 512, it will be 16 elements for a vector of floats. And you can still specify that you want only 8 elements when constructing your SIMD vector. We also changed the behavior of the memory random access Kokkos trait, memory trait. So before it implied the unmanaged memory trait, but now it only strictly say that the view will probably be accessed in irregular manner. And if you enable deprecated code 4, you will get the old behavior. So you should be careful with this. And we don't expect this to break codes because some of our huge users did the change and they didn't notice any error or something. Okay, on to bug fixes. So we fixed the bug in dual view because when calling the resize method, it would always say that the view needed to be synced, even if running on a host backends or a serial backend. We fixed the warning in MSVC related to the reduction identity. We now properly delete the copy constructors and copy assignment operators of the timer class because it would sometimes lead to link errors before, and now it leads to a compile error, which would be easier to detect. We fixed RISC-V support. It was quite broken before this release, so we did quite a few bug fixes to get it working. We changed the return type of the bitwidth function to return int instead of the type passed as argument to align with the standard library. And as mentioned before, we worked around the performance regression in the MDSpan-based view related to index computation. So this was mostly visible on GPU backends, and this should be fixed now. Okay, for heap and CUDA, so there was a small bug in Kokkos graph where the graph would be launched on the default execution space instance and not on the one provided by the user. So if you did use Kokkos graph on heap and CUDA with non-default execution space instances, now this will behave correctly. And we also fixed the bug in parallel reduce on the CUDA backend, where launching with launch bounds smaller than 32 would result in incorrect results. Okay. On OpenMP, we fixed a bug in partition space, where it would abort if you requested more partitions than how many threads were available. And on Kokkos SIMD, we fixed the failure when if you enabled SV and disabled the test, the Kokkos configure script would fail. So now you can use SV without enabling the test, and it should work fine.
Thank you, Travis. So with that, we are about the end.
Damien, can you give me
Yes. And while Christian gets set up, I wanted to mention that the tea time will happen next month. It's going to be as usual on the third Wednesday of the month, and it's going to be on December 17th. Stay tuned. We're going to post it on the announcement mailing list and on Slack. Okay, Christian, go ahead.
Okay, I'm gonna give just a couple updates on Kokkos kernels. There hasn't actually much happened in Kokkos. Oh, what is this? It's like auto forwarding. There hasn't actually much happened in Kokkos kernels, also at least not user facing, other than prepping for or being compatible with Kokkos 5. there was a lot of like cleanup of internals, like getting rid of a lot of like nasty things or things, one shouldn't do, like, using reserved identifiers in our internals, which technically C++ says you can't use. Uh, things like leading underscores and stuff like that. The Kokkos kernels team also worked on significant enhancements to the documentation. So there was a concerted push, to get the documentation into better shape. And, we hope you'll see that in the results. Then obviously, for Kokkos 5 readiness, the Kokkos kernel team now as well obviously requires C++ 20 since it only works with, the current Kokkos version. There is a couple changes, however, which are important. One of them is we moved arithmetic traits from Kokkos Core to Kokkos kernels a while ago, and you do need to enable Kokkos enable deprecated code 5 in order to include Kokkos arith traits.hpp. There is arithmetic traits, the C++ style arithmetic traits, which are part of Kokkos Core. So these type of traits here, this was kind of like the older style, traits class thing. And yeah, so if you can use the kind of C++ standard style ones, you probably should. But this we will keep this around for quite a while. Beyond that, there were some performance improvements made for PyLute. That's, I hope, most of you who use that will see that. And then there was just a bunch of like smaller bug fixes. There were issues with a batched QR, with complex values, which are now finally hopefully fixed. Then there was a bunch of reports when we run in a few issues, in particular also via spec builds and whatnot, with BLAS and LAPACK. So hopefully those should be resolved. Which were related to like BLAS includes as well as like the LAPACK interface macros, the kind of macros you need to do the, C interoperability to Fortran interfacing to LAPACK. And then last but not least, we removed usage of 4 inside of Kokkos kernels for the CUDA backend. This 4 was deprecated in CUDA 13. So, if you try to use CUDA 13, you got deprecation warnings. So we, got rid of that and made sure this is clean again. Yeah, I think that's it. Take a look at the documentation in particular, give the Kokkos kernels team some feedback on that. There was like real significant work on that. And as always, if you find problems, ping us. One last thing I think we didn't, because I'm seeing that here, the topic branch for develop, I think we didn't really mention that the master branch on Kokkos Core did not get updated. We announced that, I think a couple releases ago, that we're going to move away from it. So the master branch is not going to track the latest release anymore. The default branch is develop anyway. That has been the case for a long time. And then there's tags for the specific releases. Yeah, that's something, you should know. If you want to contribute, we're welcoming contributions as always. This has to be on top of the develop branch, so don't try to get your fixes in based on like the actual release branch. And if you have questions, get in contact with us. That said, we have time for questions now, if anybody has any. You might just unmute yourself and speak up.
Yeah, and as usual, we will on our website there is under community a release briefing tab. Later this afternoon we're gonna upload all the slides, so you can find again the information about the meetings and anything you want to look at it again. So there's a question regarding the master branch. No, we are stopping to update them in all of our repo. We are going to remove them blanket. So this is not the way anymore to get newer versions. Feel free to unmute yourself if anyone if want to react has a problem.
Yes, you can answer the previous questions that were already answered in the chat.
Sure. What specific question do you have in mind?
So there was the OpenACC, is it still supported?
Yeah, so there was a question about the OpenACC backend. So at the moment, OpenACC is still an experimental backend, but we still support it, and we still, we're not doing a focused effort to push it, but we welcome feedback on this one.
And there was a question about SIMD for SQL.
Yeah, there is no, I guess Christian reply to Tim, there's no.
There's no concert as we haven't really done anything for real with it, right? So like, I mean, the scalar SIMD type would work, right? But we haven't like actually looked into like making GPU capable SIMD types, of length larger than one. We've been thinking about it for a while. Mostly we've been catching up with, like making sure that we incorporated all the late binding changes to the standard SIMD proposal, which had, quite a bit of churn over the last, year or two. And so keeping track with that was, a pretty significant effort. That said, we have certainly discussed like the question of SIMD types with length more than one on GPUs. I thought about that quite a bit. There's some benefits for that, which might even when things like NVIDIA GPUs come out. But yeah, if you're interested in this, like get in touch with us, in particular Donghan, who is leading kind of a SIMD effort, and we can talk more.
So there was finally a pause. I'm going to be working on some alternative random number generators. Is that something that could possibly be added to Kokkos Random?
Yes, please talk to Christian and I offline. So we welcome any new generator with the current interface, but we have been contemplating for a while whether we would like to reconciliate a bit with the standard interface and just have the usual standard interface for the different pieces and just an engine for the parallel environment. So we'd be happy to discuss this with you.
Yeah, actually, it's in many respects, it's a change to where the random number key or the state is stored.
Okay.
It's
Yeah.
not actually much of a change in the generators themselves.
So if what you have already works on what's available, feel free to open a pull request. But we're happy to discuss it offline if you want.
Okay. I will reach out to you, Damon.
Sounds good. Okay. Well, thank you everybody for coming. It was good to see you all. Have a good Thanksgiving and a good Christmas and everything. And hopefully we'll see a lot of you at upcoming events, the training of the European HPSF community event and the CUG, the official CUG in Chicago. Have a good rest of the day and of your week, guys. Bye.